Okay, guys, let's do some more problems. Again, we're trying to solidify this knowledge in our memory banks, hopefully. Here we go. So on this problem 14, notice they tell us that motorcycle vehicle death rates per 100,000 people in the whole United States has a mean of 13.1, standard deviation 4.9, while firearm death rates under the same conditions has a mean of 12 with a standard deviation of 3.7 deaths. Okay, so we are comparing normal curves here, guys, and this is a very common problem. So what's the first thing we need to do? We need to sketch these so we can compare them. Okay, your sketches obviously do not have to be perfect, but we know, let's say this is the motor vehicle and this is firearms. Okay, well, the motor vehicle, we're told they average 13.1 deaths, okay, per 100,000, and standard deviation's 4.9, right? Whereas the firearm averages a little bit less, 12, sorry about that, with a standard deviation of 3.7. Okay, so the question says, well, what would be the firearm death rate? So we're going to question this over here, that has the same z-score as a motor vehicle death rate of 15. So 15, I hope you agree, is somewhere about right here. Okay, so let's find its z-score. Now, how do we do that? Remember, guys, it's almost like doing a test statistic. We take what we want or given, like in our sample in this case, we want 15, right? We compare it to our mean, in this case 13.1, and we divide by the standard deviation. So this is going to give me my z-score. And we want this, the z-score, the same z-score over here. So first things first, 15 minus 13.1 is 1.9. We divide by our standard deviation, 0.38775, right? Well, I kind of ran out of room here, so guys, hopefully you don't mind me erasing this. So now that we know our z-score for motor vehicles was, again, 0.38775, we want the same z-score for firearms. So this z-score is going to equal, well, we don't know what the firearms is, so it's got to be here somewhere, right? So x minus, what is the mean for firearms? So you always take what you want or what you're comparing with, what result in a sample. You minus that from the mean. You divide by the standard deviation. So the formula is basically this, guys. Right? That's how you find a z-score. So we have a simple algebra equation here, right? All I need to do is take this times 3.7, and whatever that is equals x minus 12, right? Because if I times by 3.7, I get x minus 12 equal to whatever this is, right? And then therefore all I need to do is add 12 to that. So here we go. We're going to times by 3.7. We're going to get 1.43, da-da-da-da-da. We're going to add 12, and so we end up getting 13.43. And if we look at our choices, the only one that's closest is 13.4. So the correct answer was A. Very common problem on an AP Stats multiple choice exam, by the way, guys. They always have you analyze normal curves, and they always love you to compare one normal curve to another. So we got to make sure we're prepared for that. Okay, let's go on to the next one. Now, guys, this one should be very straightforward. Should be. Remember, if we were talking proportions, right, the standard deviation for proportions would be P1 minus P over n. If we were talking means, the standard deviation would be whatever the sample standard deviation was divided by square root of n. The whole point is, remember guys, sample size, you're dividing by the square root of the sample size, in essence, right? So if we want to be 3 times smaller, margin of error wise, cut it by 3, we want our sample size to be, the square root of it to be 3 times larger. Well, that means 9, right? Because the square root of 9 is 3. If they wanted to be 4 times smaller, then it would be 16. If they wanted to be 5 times smaller, it would be 25, and so on. 10 times smaller would be 100, right? Because you have to take the square root. So in our, long story short, guys, we want it to be, I miswrote it there, we want our sample size to be 9 times larger, right? Because the square root of 9 down here would be equivalent to a 3. And I hope you understand that. So therefore, if our original sample size was 270, and we want to be 3 times more, or less, more precise, less standard deviation, right? Our margin of error 3 times smaller, cut into a third. We want to be, therefore, 9 times larger sample size. So we're just going to times by 9. See, 63 carries 6. So as you can see, guys, we want our sample size now to be 2,430. All right, let's do one more. Number 7. Now, guys, this one, again, should be pretty straightforward. Notice our null hypothesis. We're trying to compare Division I with Division III football programs. And just to add a little reality, guys, understand, to be in Division I, generally, it's very more competitive, right? Oh, my grammar's terrible. It's more competitive, right? And so Division III, in essence, they're usually generally more desperate to get quality football players. So they have generally lower academic standards, potentially, not always, but potentially, okay? So anyways, that's the reality situation, all right? But anyways, notice we're going to assume they're equal to each other, right? Hey, no, Division I, Division III, they have the same standards, et cetera, et cetera. Notice we're suspecting that Division I will have smaller GPAs. Ooh, I have them thinking backwards, don't I? A smaller GPA means, let's think about that. Yeah, I guess if you think about it, guys, let's say you're a University of Alabama. You want this, one of the best athletes, football athletes in the country. There's a good chance that athlete's probably not that good in school, right? Or a better chance. So, you know what? My thinking is backwards on that. See, you can learn even at an older age like me in this class, guys. So long story short, they're suspecting that Division I will have lower standards because they want the better athletes to compete and win championships with, right? And Division III is more competitive. So yeah, I guess that makes more sense because the Division III would be like a private school. And if you think about it, guys, private schools, they're going to definitely have higher standards, right? So they are suspecting that Division I will have a lower GPA on their football team versus the Division III. And we are told, look right here, the p-value came out less than 5%. So remember, guys, when it comes out less than 5%, we reject H0. And therefore, we have sufficient, I know my writing is terrible here, but I'm saying it correctly. We have sufficient evidence that basically we're rejecting H0 and the alternative HA is therefore true, right? And if you look at our choices, guys, notice you can't pick A because it says you cannot conclude that the difference is significant. B, you cannot conclude it's significant. C, you cannot conclude it's significant. D, you cannot conclude. So this is a rarity, guys, where they make it pretty easy for you if you know what you're doing. Remember, generally one of these will be another you can conclude, and then you have to pick which one is the better explanation. So long story short, as my phone is ringing, the correct answer is E. So guys, as I was saying, I had a phone call there. So anyways, I'm pretty sure I covered all the problems, and I'm done with this video. Please make sure you do study problem by problem and you truly understand them. If not, bring it up in class so we can have a nice discussion. All right? See you in class.